Okay, we're going to look at number 1. It says determine if they're similar. So what we want here is we want these things to be proportional. Okay, so I look here and I already actually matched up what goes with what. And I'm just going to put in a proportion, which we remember are fractions that are equal. So I have 12 over 3 to start out with. So if I'm doing 12 over 3, be consistent. So I went here over here, so let's go here over here. Equals 20 over 5 equals 8 over 2. And we just want to simplify. So that simplifies to 4 over 1. That simplifies to 4 over 1. That simplifies also to 4 over 1. Which means, yeah, they're proportional. So, yes, they're similar. And it wants the scale factor. So I have a scale factor, and they want the simplified. So scale factor of 4 to 1. I then have here, okay. So looking at this, it says determine if they're similar. Same thing, let's set up our proportions. So here I might go 8 over 12. Equals 6 over 10 equals 6 over 10. Simplify. So here 4 goes into each. 2 goes into each. Same thing, 2 goes into each. However, this is not the same. Therefore, this is not similar. And remember, you can't give a scale factor if it's not similar. Okay, so looking at number 5, the main thing that changes is it's saying find the scale factor and find these ratios. Therefore, we're going to assume that these things already are similar. So if they're similar, I don't have to check every single measurement to make sure that everything's proportional. Let me just pick one. So if you're given a choice like this, I would recommend using these two numbers because that one is going to be more in your head. You'd have to double this and then simplify. So let's just use these two. So what I'm going to do is I'm going to say 4 over 6. And that actually simplifies to 2/3. So that already is my scale factor, 2 to 3. It's as simplified as possible. Now here's the thing about scale factor. This is A to B. That's why we were using these linear measurements. They're not millimeters squared, cubed. These are just millimeters. So this is A to B. Surface area is going to be A squared to B squared. And volume is going to be A cubed to B cubed. So what do I have to do? All I have to do is start here. And we're just going to go here and here. So if this is squared, we're just going to square each. So this is really 2 squared, 3 squared, which is actually 4 to 9. This is, remember, you're not going from here to here, you're going back here. So here we have 2 cubed and 3 cubed. So I have 8 to 27. So those are my answers, how my ratios would look for these. Number 6, pretty similar. Probably the best drawing I've ever had, so go ahead and just look at that one for a while. Not going to happen again. So it says find the scale factor. This one, instead, if you look at these squares, I already know I'm not going to be using linear measurements here. I'm going to already be here, which is A squared, B squared. That's actually where I'm starting with. And my two numbers are 25 and 4, okay? So what I want to do is I want to simplify that. Does any number go into both of them? No. Therefore, that actually isn't simplified. So this is 25 to 4, but here's the thing. I want to get back to A to B. So how do I get from here to here? You're getting from A squared, and you're undoing the square. Therefore, what you're actually doing is square rooting. Because when you square root each, it goes away. So really, that's what we want. So what's the square root of 25? That's 5. Square root of 4 is 2. So this is 5 to 2. Okay? Now that we have here, we can go to volume. So we always want to get back to scale factor first. So volume is going to be a cubed, b cubed, and we're going to be using these numbers. So it's 5 cubed and 2 cubed, and what is that, 125 to 8. Okay, let me just double check that we're good to go. Yep, on to the next one. Just going to show you one of these just because the first one had scale factor, the next one had surface area, this one starts with volume. So you can probably figure out what we're already doing, but let's go through it. So volume, I see those cubes, I'm good to go. So I have 162 to 384, and if I'm right, 6 went into each of them. So I divided by 6, divided by 6. You ended up with a simplified 27 to 64. That, remind you, is volume. So this is 27 to 64. So this is currently, sorry about that, this is currently a cubed to b cubed. Yet again, I want to go back to scale factor first. So how do I get from a cubed, b cubed to ab? Instead of taking the square root, we're taking the cubed root. Okay, so we got to cube root these. So cubed root of 27 is going to give us 3. The cube root of 64 is going to give us 4, so that's my scale factor. Now that we have scale factor, I can go and solve everything else, which in this case is going to be surface area. Surface area is a squared b squared, so that's all I'm doing. I'm going to say, okay, 3 squared, 4 squared, 3 squared, 9, 4 squared, 16. Ooh, onto some nice ones. Okay, so it's going to be switching it up. We're at the end of that section, starting this next section. It says solid A is similar to solid B, so we're already assuming that there's going to be a scale factor here that we can work with. The ratio of the height of A to the height of B is 7 to 3. So height, we're thinking linear here, okay? So this is going to represent scale factor. Because remind you, we're not talking about squared and cubed here. We're just talking about height. That's just a linear measurement. So I have a scale factor of 7 to 3. They want to find the ratio of the volume. So volume, I'm already thinking, okay, I already know scale factor is A to B. I want volume. The ratio for volume is A cubed, B cubed. So I take these and I cube each. So now we got to go, okay, that's going to be 7 cubed, 3 cubed. 7 cubed is going to be 343. 227. That's going to be my answer there because I did find the ratio for that already. Number 10, cones. Love it. So this now is giving me that the surface area of one to the surface area of the other is 16 to 1. Make sure you're still going with the same B to A here. So B to A, surface area. Surface area, 16 to 1. Surface area is A squared B squared. So we want what? We want ratio of the radius. Radius is linear, so we actually just want the scale factor, which is A to B. So how do I do that? Well, to get from here to here, we want to square root, square root, square root, square root. And that gets us to be a scale factor. And in this case, it's also the radius ratio of 4 to 1. Okay, so that's what we got there. Moving on to the beautiful cylinders. So cylinder here and here are similar if cylinder A has a diameter. Yet again, another linear measurement, so that makes me think of scale factor. Okay, so we have a scale factor of 24 and B has of 30, so let me get that. A to B scale factor is 24 to 30. I already see that definitely we have some numbers that can go into this. This can already be simplified, and I already know that 6 goes into each. So let me just divide each by 6. I like them to be simplified as much as possible. This gives me 4 to 5. So that reminds you, because it's diameter and it's linear, that is the scale factor. Let's look at what we want. Really, I should have done that first, but I already know what they want. So volume. Volume is A squared to B squared, and they want A to B, so I'm good, A to B. So I need to take this 4 and cube it. I'm sorry, I think I said squared, it should be cubed. Sorry. 4 cubed, so 4 times 4 times 4 is 64. 5 cubed is 125. And that's your wonderful answer. One more to go into our pyramids. So pyramids, we have volume. So this is kind of cool. We're starting with the volume. We haven't had one of those yet, as far as I know. So that's A cubed. B cubed is currently, A to B is 648 to 1029. It's a good thing I simplified this before. Divide by 3, divide by 3. That gives us a simplified answer of 216 to 343, and that's as simplified as possible. Now let's think, this is volume. Okay, what do we want? We want surface area. If you think back to the problems that we did, we can't jump from surface area to, from volume to surface area. We first have to go volume to scale factor, which that's volume. This is scale factor, and then we can go to surface area. Okay, so that's its ratio, scale factor here. So how do we get from here to here? Here to here, you would do cube root, so that's what I'm gonna do. Cubed root, cubed root. So when I cube root all of those, I get 6 to 7. So this is where I am. I don't want that. You want surface area, so I am going to go from here, so I need to square both of these. So 6 squared is going to be 36. 7 squared is 49. And that's us done. You actually have, I included extra parts of the notes. You don't really have to do it. If you do want to do it, totally go for it. I left an answer key for it, but really for the homework, you should just be able to do this. See you later, guys.